Hi, my name is Anton Averchenkov. I'm an engineer here at HashiCorp working on the Vault DevOps team. And today I'll be presenting with my teammate, analyst Diroff. We'll be talking about Vault OpenAPI-based client libraries and workflows. In particular, we will first cover the basics of the OpenAPI specification. We will then discuss how OpenAPI is generated and used in Vault, and how you as a plugin developer can improve the OpenAPI spec generated for your plugins. And finally, we'll showcase two new OpenAPI-based client libraries that we've been working on, vault-client-go and vault-client-dotnet. All right, let's begin. So first, what is OpenAPI and why do we need it? OpenAPI specification is a language-agnostic industry standard for declaring and describing your RESTful APIs. It's a very simple YAML or JSON file that is readable by both machines and humans. But it's incredibly useful and powerful. It can be used to generate both client and server code in dozens of different languages. And it can also be used to generate documentation or even automated tests. It is currently maintained by the Linux Foundation as part of their OpenAPI initiative. Here's what a typical OpenAPI file looks like. This is a YAML example. It's essentially a collection of path objects, each of which has one or more operations, such as post, get, delete. The path and the operation can be translated directly into a REST call, and the rest of the elements can be easily mapped into the code. So for example, the operation ID is typically translated into the method name. Okay, let's see how OpenAPI is used in Vault. Vault is a bit unusual in its usage of OpenAPI. The spec is generated dynamically from the loaded plugins rather than having a static source of truth file. You can access Vault's API spec by calling this internal endpoint. Alternatively, you can run gen OpenAPI.sh script, which loads all built-in plugins and calls the endpoint for you. It is also worth mentioning that Vault's OpenAPI spec is not yet officially published, but we are very close to publishing it. So within Vault, it is used by many UI components. It's also closely integrated with the help text. For example, you can call Vault path help to fetch OpenAPI-like description for your given path. And most recently, and most importantly for this talk, we have started using the spec to generate two new OpenAPI-based client libraries, Go and C#.NET one. Once we release the spec, more libraries will soon follow. Alright, let's hop into the demo. I'm going to show how we can generate and modify the Vault OpenAPI spec. I'm in the Vault directory. Let's take a look at gen OpenAPI.sh script. As I mentioned, it's a very simple script. We start up a dev instance of Vault, then we mount all the built-in plugins. And at the end here, we call OpenAPI endpoint and redirect the output to OpenAPI.json. Let's run it. So it generated a fairly large file, almost 50,000 lines of code. Inside, it looks like a fairly typical OpenAPI spec file. Now, let's assume I wanted to modify the OpenAPI output for KVV2 read configuration request and its response structure. I happen to know that the plugin used to generate this is vault plugin-secrets-kv, and I already have it cloned. Let's take a look at the path-config.go, which is where our endpoint is declared. This is a fairly typical path declaration. There is a regex pattern followed by display attributes, which allow us to modify the OpenAPI operation ID. Below you will find the request fields and a list of operations. The read operation is the one that we want to modify. Let's change the operation suffix, which will modify the operation ID. I'm going to add -demo at the end. And for good measure, I'm going to modify one of the response fields, max versions, to be max versions _ demo instead. You'll notice right away that we broke some tests. This is expected because we're calling a few test helpers to validate that the responses match the declared response schema. Since we've changed the schema, but not the actual response, the tests alert us that there is an inconsistency. To fix the test, you would simply adjust the response names to match the schema, but we don't need to do that now. Instead, let's build the plugin and load it into Vault so that we can see the new OpenAPI schema. There are a couple ways of doing it. For built-in plugins, I can just use a replace directive in my Go mod to link against my local version of the plugin, but I'll show a slightly more complicated method that should work for any plugin, not just the built-in ones. In order to do that, we need a regular non-dev instance of Vault. So luckily I have a script here for that. I'm going to modify our gen OpenAPI.sh and replace vault server-dev with vault server-config. And then I'm going to copy the rest of the code here. This code block first initializes our local vault. It then unseals it with the unseal key, and then it logs in with the root token. This is not a very secure way, but we're using it just for the local OpenAPI generation, nothing else. Let's also copy the Vault config file. As you can see, it's very minimal. And let's run our gen OpenAPI.sh script again. We should expect the same output. Oops, it looks like there was a permission issue. Let's try to debug it. Ah, right, I forgot to update the root token when curling the OpenAPI endpoint. Let's update it. Okay, much better. So to promote our changes into OpenAPI locally, let's actually load our KV plugin. To do that, I'm going to create a my plugins directory under the scripts where our test vault is run. And I'll copy the plugins binary into it. We'll also need to mark my plugins as a trusted plugins directory in Vault's config. And finally, we want to register the plugin. The plugins README here has the exact command. Let's copy this command. We'll also need to generate a SHA-256 sum of the binary. This SHA-256 is used to protect against rogue binary injections. Okay, we're all set. Let's back up our OpenAPI.json and run the script again. As you can see, the OpenAPI spec was modified to reflect our changes. We have the max versions demo and the KVV2 read configurations-demo operation ID. And just to summarize what we did in this demo, we modified Vault plugin secret KV plugin, ran the test to discover the validation failures, built it, then modified our OpenAPI script to start a real non-dev Vault instance. We registered the plugin's binary, and finally we ran the script to see a new OpenAPI.json with slightly modified fields. For the official release of the OpenAPI spec, we're planning to simplify this process with CI automation, but I think it is still worth understanding how to do it locally. On the next few slides, I'll cover a few suggestions to make the OpenAPI for your plugins even better. First, when you're constructing the regex for your path pattern, make sure to take advantage of the Vault regex helpers. Custom regexes may not work very well with the OpenAPI. Next, if you have endpoint specifically for list operations, it should end with a slash. This is a convention we've been following with Vault and OpenAPI spec. For better documentation, be sure to populate the summary and description fields at the path and operation levels. The next three I'll cover in a bit more detail, but to summarize, framework.fields will map to a request object in OpenAPI, response.fields will map to a response object, and display attributes operation fields will map to operation ID, which in turn translates into a method name in the generated code. So framework.fields that you can see here will be used to generate the request body object in OpenAPI. The one exception to that are path parameters. They will be present in framework.fields but excluded from the generated request body. Response fields map is something we've introduced quite recently, and it will be mapped to the response object corresponding to this operation. You only need to define the successful 200 level response schema here. As you've seen in the demo, we have a few test helpers that allow validating responses against response schema, and you're highly encouraged to use them. Finally, be sure to populate the display attributes with the operation prefix, verb, and suffix. These will be translated into operation IDs by concatenating the three parts into one hyphenated string. And the operation IDs will map into the method names in the generated code. If any of the prefix, verb, or suffix are omitted, the OpenAPI code will attempt to fill these with reasonable defaults, like the verb would default to the operation name. But if you want to control the names of the generated methods, be sure to populate all three prefix, verb, and suffix. So one of the best uses of OpenAPI spec is generating client libraries. And we now have two new libraries currently in beta, vault-client-go and vault-client-dotnet. Let's take a look at vault-client-go first. Once it is fully released, it will be a successor to the existing Go library that we currently have under Vault API directory in the main repo. Alright, let's take a look inside. Here we have a number of handlebar templates that are specific to this repo and I used to generate the code. And this is what the generated code looks like. Let's find our kvv2 read configuration function. This one is still referring to the previous version of OpenAPI.json, but we can easily regenerate the code. First, I'm going to copy the OpenAPI.json file we just generated into Vault Client Go's directory to override the existing one. And then I will simply run make regen to regenerate all the files. And now, as you can see, both the request name and the response name have been modified. And max versions demo as well. Great, now let's see how to use this library. Here I have an empty directory. I'm going to navigate to GitHub HashiCorp Vault Client Go. And copy over the getting started example. Next, let's run go-mod init and go-mod tidy. Let's also start a dev vault server in the background. And just like that, we're writing and reading our first secret. So there are many awesome things that you can do with this library, but I'll just demo a couple more. First, when you initialize the client, you can pass in various options using with-x pattern. For example, I can configure the client to pull in environment variables using vault.withEnvironment call. And now my client respects vault_adder environment variable. Similarly, each request can be decorated with various modifiers. For example, here I'm adding a request callback to print out the request before it is sent. Most of these request modifiers also have global client level analogs as well. For example, client.setRequest callbacks here. And now the request is printed out as expected. This is it from me today. Thank you for listening. And now on to Anna to discuss another OpenAPI-based library that we've developed, vault-client-dotnet.
Hi, my name is Annalise Diroff. I'm an engineer on the Vault DevOps team. Today I'm going to be showing off the .NET client library that's based off the OpenAPI spec for Vault. I'm going to create an application from scratch. I'm going to show you how to add the .NET library to that application, and then I will read and write a secret from Vault using that library. I'm also going to show off some of the functionality that we built on top of the base generated library. And then I'll also show some of the workflow and how we actually generate the library from an OpenAPI spec. So first things first, I'm just going to create a new application. .NET has a scaffolding tool that will just create all the files that we need from scratch. So I just created a Consul application. You'll just see it does a basic hello world. And I'm going to hop over to NuGet. So this is where our HashiCorp Vault package lives. It kind of shows you how you can include it in your project. I find this using the .NET CLI tool to be pretty straightforward. So I'm going to go ahead and copy that and use the latest version. So I'm going to paste this into our project, and it should add everything we need. So if we go to our CS proj file, we'll see that it's added HashiCorp Vault as a package reference. Perfect. Okay, so now I'm going to hop over to our Vault client repo. So this is the vault-client-dotnet repo. It is currently public in beta right now. And the README has a lot of examples how to install the library and how to use it. It has getting started and some of the custom functionality that we talked about as well. So if we scroll down, we'll see that we have some examples. There's a very basic getting started example. So in the background right now, I have a Vault dev server running with my token set as the root token ID. So this should work. This example should work for us. So I'm going to go ahead and copy this, and I'm going to paste it in our program CS. So I'm going to overwrite all this here. Okay. So now we can go ahead and go over the code. So what you do with this client library is you create a basic Vault configuration. It only requires an address. So right now we're just pointing it to the local Vault instance I have running. And then we can use that configuration to create client. I am then setting the token, which is the root token that I gave to Vault. Typically, you'd want to use an authentication method like April, but in this case, this will work for demonstration purposes. And then we're going to go ahead and write to the KV-v2 backend. We're just going to write a basic password, and we're going to write it to the path, my path. And then we just read the secret back. So we're just going to read it from my path, and we're going to print out the data. So if we go ahead and run this, we're going to go see this should work without any intervention. And Bob's your uncle. We got our password back, and it works just fine. Okay, so now that we've created a basic application, I wanted to run through some of the things that the library can do and some of the things that we care about. So for example, if we look at the Vault client, some of the things that we care about, we have auth, so that this object is going to contain all of our auth backends, so things like April login, if we wanted to use that. You'll also notice that each call has both a synchronous and an asynchronous endpoint, so we support both. There's also identity that has all the identity related calls. And then we also have things like secrets. So this is going to be your KVs. There's also cubbyhole, and all of the secrets engines that are built into Vault are under there. Finally, the other main object that we care about is system. So this is going to have things like sysmounts and monitor and wrap and unwrap. So those are the main high-level objects. I'm going to hop back over to our README to show off a little bit of the custom functionality we have. So there is currently, with configuring a client, you can do a few custom configurations, such as set a custom timeout. You can also set a custom HTTP client handler, which is a .NET thing that is effectively like a request callback. You can also, we allow for setting certain types of headers. So you noticed we used set token to set the header token that would go with each Vault request. We also have the ability to set and clear namespaces. And then we also allow you to pass in custom headers as well. We kind of saw a little bit about Vault authentication, but again, all the auth endpoints live under this auth object. So if you wanted to do app role login, you would call the login function, create the login request object, give your role ID, give your secret ID, and then that should do it. Another thing that we allow for is overriding the default mount path. So if you're not using the default mount path, all endpoints have an option to override that and provide your custom mount path that you're using. And we've already seen reading a KV secret. We also allow for you to wrap and unwrap responses. Another really important one is performing generic operations. So if you have a plugin that is not native to Vault, it's not built into Vault, it will not be built into the library. So you can use the read and write generic operations to interact with those backends, with those custom backends. Okay, so now that we were able to successfully read and write a secret to Vault using our application and our .NET Client library, we're going to hop over to a new instance of VS Code that I have the vault-client-dotnet library open in. I kind of wanted to go over some of the code in here and the way things are structured to make it a little bit easier to digest. So a couple things, we have the OpenAPI JSON in the root of the repository. This allows us to generate the library from scratch. It likely will not be living in here forever as a source of truth, but for now, this is a place you can find it. So you'll see path names and all the parameters, etc. And then the templates that we actually use to generate the code are under this generate folder. If you pop open the templates, you'll see there are a bunch of handlebar templates, and they're all in this handlebar format. They basically just allows us to, inject certain things into the code. So you'll notice the structure of the code looks similar to C# with some things redacted that are injected with either the config or with the OpenAPI spec. And then we also have the source folders. So this is generally the auto generation. So most of these are auto generated, and you do not want to be messing with these because they'll just get overwritten. So we have our main Vault client. So this is, you'll notice it has the auth, identity, secrets, and system. So those top level things. And it's got, this is just basically how you would normally initialize it. And then inside you have the API. So these are all of the implementations and the interfaces for the different endpoints. So there's all the AWS things, all the Azure app role auth. We also have our identity endpoints and our secrets and our system as well. And then if you pop open the client, this is just basic other kind of ancillary things like the configuration, the client, exceptions, things like that. And then in the models, we have all of the request and response models. So these are objects that you would pass to an endpoint that would contain all the request information or the objects that you would receive back, like the response models. And we also have a makefile. So this hopefully makes things a little bit easier, but I'm not going to run these regens because they take a little bit of time. There's a lot of files to generate. But the regen will delete all the generated files. It will generate everything and format and clean. And the regen bin will build it and create a binary. And if you want to develop locally, you can regen and use the bin and copy and paste the binary into your directory to test or play around with. I think that about covers it. So thank you so much, and please give it a try and let us know what you think. Thanks.